Imagine a time long ago before written history. The year is 663 BC. A massive solar storm, unlike anything seen in recorded history, slams into Earth. How do we know this happened? Trees whispered this secret to us. Deep within their rings, trees hold a record of Earth's history year by year. Scientists like detectives can read these rings and uncover events from the distant past. The year 663 BC stands out. The tree rings show unusual changes, a chemical fingerprint unlike any other year. This fingerprint tells us a powerful solar storm, a Miyake event, occurred. These events are incredibly rare, happening only a handful of times in the last few thousand years. But when they hit, the effects are dramatic. The 663 BC event was so powerful, it left its mark not just in trees, but also in ice. Scientists drilling deep into the polar ice caps find more clues. A spike in certain radioactive elements, confirming the solar storm's fury. These discoveries highlight the incredible power of nature and our ability to uncover its secrets. Trees and ice, these are nature's time machines. They hold a detailed record of Earth's history, stretching back thousands of years. Every year, trees grow a new ring, a marker of time. The thickness and composition of each ring tell us about the climate and conditions of that year. Ice cores extracted from glaciers and ice sheets are like frozen time capsules. They trap layers of snow year after year, preserving dust, gases, and even radioactive elements from the atmosphere. By analyzing these layers, scientists can reconstruct past climates, volcanic eruptions, and even solar storms. These natural archives provide an invaluable window into Earth's past. They help us understand how our planet has changed over time and the forces that have shaped it. And sometimes they reveal extraordinary events like the ancient solar storm of 663 BC. Miyake events are not your everyday solar storms. They are the giants, the superflares of the sun. These events are named after the Japanese scientist Fusa Miyake, who first identified them. What sets Miyake events apart is their intensity. They unleash a torrent of energy and particles far more powerful than typical solar flares. This energy surge leaves a unique fingerprint, a spike in radioactive isotopes like carbon-14 and beryllium-10. These isotopes are created in the atmosphere when cosmic rays, energized by the solar storm, collide with atoms. By measuring the levels of these isotopes in tree rings and ice cores, scientists can pinpoint when these events occurred. It's like finding a radioactive signature, a clear sign that a Miyake event has left its mark on Earth. Section 4. Dating the past. Dating a solar storm that happened thousands of years ago might seem impossible, but scientists have a few tricks up their sleeves. Tree rings and ice cores both act like natural calendars. Each ring in a tree represents a year of growth, and each layer in an ice core represents a season or year of snowfall. By carefully counting these layers, scientists can create a timescale, much like the rings on a tree stump tell us its age. But to pinpoint the exact year of the 663 BC event, scientists needed more. They used a technique called radiocarbon dating. This method measures the decay of carbon-14, a radioactive isotope that's absorbed by living things. By comparing the amount of carbon-14 in a tree ring or ice layer to known levels in the atmosphere, scientists can determine its age with remarkable accuracy. This is how we know for sure that a powerful solar storm, a Miyake event, struck Earth in 663 BC. Section 5. A stark warning. The discovery of the 663 BC solar storm is more than just ancient history. It's a stark warning. Our modern world is heavily reliant on technology, satellites, power grids, communication networks. All of these are vulnerable to the effects of a powerful solar storm. A Miyake event today could disrupt our way of life, causing widespread blackouts, communication failures, and economic damage. Imagine a world without GPS, internet, or even electricity. That's the potential impact we face. The 663 BC event reminds us that the sun, while life-giving, can also be a source of immense power. By studying these past events, we can better understand the risks and prepare for the future. It's a reminder that we are part of a larger cosmic dance, and the sun plays a leading role.